I am Priya Soni. I have worked on project Real-Time Dashboard for FSM CP Lab under mentorship of Khushbu Singh ma'am. First of all, I would like to give a quick overview of the project. The FSM CP Lab consists of three interconnected workstations where the order is processed. The client code receives messages from various nodes at workstations and pushes data into Firestore database accordingly. One of the problems faced is that the user cannot monitor the process from some remote location. One solution could be to develop a dashboard which will take values of PLC from Firestore and display data in real time. Following were the main objectives behind developing this project: to create simple and easy to use interface, display real-time data, visualize data, and ability to monitor the process remotely. Following are the steps I undertook while developing this project. First of all, I understood the working of backend code, which consists of client and server code written in Python, which simulates the working of workstations. After that, I worked on wireframes using Figma, designed the dashboard using HTML, CSS, JavaScript, React.js, and Material UI. After designing, I started linking of dashboard with Firestore to retrieve workstation data. After complete linking, I worked on testing of dashboard using the backend code. The dashboard developed is a single-page web application consisting of sign-up page, login page, workstations page, and user profile page. The below video represents working of sign-up page and login page. So this is the sign-up page of the dashboard. If a user wants to log in, the user can click on already have account login link, which will redirect to login page. If a user wants to sign up, the user can click on create your account link, which redirects to sign up page. On sign up page, the user is required to enter details such as username, email, first name, last name, etc. Also, the account is created only if a user with such email ID doesn't exist. Also, the sign up page checks whether password and repeat password match. After successful sign up, the user is redirected to the login page. After successful login, the user is redirected to the workstations page. Moving on to workstations page, here the real-time data of workstations is represented using various cards, charts, progress components, and an order history table. Here on the workstations page, the above three cards represent information for the three workstations such as name, status, power, pneumatic, and progress bar. The below performance parameter represents the graph of real-time data of various parameters of workstations such as quality, performance, OEE, availability. On the rightmost section, current time is displayed and there are 4 progress bars, 1 for overall status of order and 3 for individual workstations. Below the graph, there is information such as user, inventory, part number, and pressure. Part number can be of two types, 5/2 and 3/2. Pressure is 0 when pneumatic is off and it is 100% when pneumatic is on. Below is a table for order history, which represents information such as order type, which can be 5/2 or 3/2, timestamp, the time on which the order was received, status, which can be good or defective. So this is the backend code which consists of client and server files. First of all, the client connects to Firestore and subscribes to all the nodes. The server code asks whether to turn Evon on. As Evon is turned on, power and pneumatic of all workstation is turned on. Order status would change to waiting for order and workstation 1 status would change to waiting for pallet. Also, server asks whether to place pallet and whether to place order. In reality, the order is received from an app and after the receival of order, an operator is required to place the pallet at workstation 1. The status in a workstation card represents overview of the status, while the status about linear progress bar on the right is checking details. The graph here is a real-time graph which fetches values for parameters of a workstation and is developed using chart.js starting library and plugin streaming. In workstation 1, the gripper reads the RFID tag from the palette and places appropriate valve body into the palette. After the valve body is placed, all the faces are scanned to check whether the profile matches or not. After the order gets processed in workstation 1, the status would change to completed and the server would ask whether to start a process for workstation 2. Also, when clicked on individual cards for workstations, the graph for that workstation would be displayed. So currently the graph for workstation 2 parameters is displayed. In workstation 1, the gripper obtains x and y coordinates of the whole of the valve body and places spool accordingly. After the order is processed in workstation 2, the server asks whether to start process for workstation 3. In workstation 3, parts are assembled and screwing is done. The server also asks for input for the number of parts. Currently, the graph for parameters for workstation 2 is displayed. After the order gets processed in workstation 3, all the values of workstation will be initialized. Also, the status for all three workstations would change to waiting. Moving on to our next page, which is user profile page. Here, the user can edit his or her details and click on Save Changes, which will update the details. The user can also change password by clicking on Change Password. Here, the user must enter correct old password, otherwise the password will not be updated. What I think is innovative about this project is its simple UI and various visual components which display data. Following are the outcomes of this project. The web application developed can be accessed from anywhere via laptop or desktop. It has simple user interface. A user can easily monitor the progress of order. The scalability of the dashboard can be enhanced by including more components to display data for more workstations. Thank you.
FSM, Smart Manufacturing Simplified.